All right, so we're keeping on with organic chemistry. So you can see there's varied questions that they can ask you. So normally this question will be first up on your question paper, question 2, question 3, question 4 normally. The first question is really just a basic understanding or basic questioning of your understanding of organic chemistry. So you need to know general formulae, etc. You need to be able to draw structural formulae, to draw out the molecules, and to know the difference between a condensed molecular formula and a structural formula. So make sure you know that. All right, so let's look at our next question. It says a test tube containing a straight chain organic acid, X, ethanol, and a catalyst is added was heated in a water bath as illustrated below. All right, so there's a picture of our little apparatus and our setup. So I've got a Bunsen burner, a tripod, water bath, etc. So in the test tube, I've got a compound X, and I've got an alcohol, and I've got a catalyst. Okay, they say organic compound Y is produced according to the following reaction. So, okay, you can't really see the arrow too clearly here, but there's an arrow over here. So these are my reactants. I've got X plus an alcohol, and my arrow is very wonky. Let's just draw in a decent arrow here. If I can just draw it straight in there. All right, so there's the arrow going to product Y and water. All right, before I even continue with this, I know that this is an esterification reaction. So here they could introduce a little bit of organic reactions, but we're going to focus on that next week, organic reactions. So that's esterification. Another word for esterification is condensation. So this is an esterification reaction. So it's the making of an ester. And to make an ester, we use an alcohol and a carboxylic acid. So first question says, give a reason why we have to use a water bath. Now this is a very commonly asked question, either referring to the water bath or referring to one of these properties of organic compounds. Most of your organic compounds, in fact all of them, are very flammable. Ethanol is flammable, so we can't heat it over a direct flame, so we make use of a water bath so the water can heat up evenly and that is not exposed to a direct flame. All right, so the first question is nice and easy. Why do we use a water bath? Because ethanol is flammable and we want to avoid contact with the open flame. All right, so let's write that down. So ethanol is flammable and we want to avoid contact with an open flame. All right, there we go, nice, easy, 1 mark. Okay, next question, write down the type, oh look there, write down the type of reaction that takes place here. So we can just say esterification or condensation. Esterification, there we go, it's the making of an ester. The formula of the catalyst needed. In organic chemistry, always remember 99% of the time the catalyst used is concentrated sulfuric acid. You could also use phosphoric acid. The most other one that we could use is platinum, but we only really use platinum in the hydrogenation reactions or dehydrogenation reactions. All right, so we were adding hydrogen or removing hydrogen, but everything else, just learn concentrated sulfuric acid will be the catalyst that we use. Okay, so this one, sulfuric acid. All right, so the formula, so always remember to answer the question. They wanted the formula, not the name, so H2SO4. Now they want to know the homologous series to which Y belongs. So we identified that this is an esterification reaction, so obviously Y is going to be an ester because we make an ester during esterification. So what is Y? Y is a ester, and there we go. Good, so nice and easy. Next one says, the molecular mass of compound Y is 144 grams per mole and its empirical formula is C4H8O. ladies and gents, so empirical formula means the simplest ratio. Doesn't mean that is actually what we're working with. So it's just the simplest ratio. So the carbon to hydrogen oxygen ratio, the simplest ratio is 4 to 8 to 1. So it could be double that, it could be triple that, but the empirical just means the simplest. All right, so how are we going to answer this? So first of all, you go work out the molecular mass of C4H8O and compare it to 144, and then we can see the factor that we need to multiply those coefficients with. So let us have a look. All right, so the first thing we're going to do, we're going to go work out the molecular mass of C4H8O. So it's going to be 4 times, carbon has a molecular mass of 12, plus 8 hydrogens multiplied by 1. The mass of hydrogen is 1, plus oxygen is 16. So if we add that all together, all right, let's have a look. So 4 times 12 is 48, plus 8, plus 16. So if I add that all together, I'm going to get 72. You can just double check me at home on your calculator. So 72 grams per mole. Now what we do, we compare the molecular mass of the empirical to the molecular mass of the actual mass of compound Y. So they said mass of Y was 144. So this was 144. This is 72. So we divide by the smallest number throughout. And I see I get a factor of 2 to 1. So therefore compound Y is going to be equal to double C4, double H8 and double O1. All right, so we just have to multiply by a factor of 2 throughout to get the molecular formula. So let's have a look. So this is going to be C, 4 times 2 is 8. Hydrogen is 8 times 2 is 16. Oxygen, there was 1 and it's O2. And there we go. All right, so now we've got the molecular formula of my compound Y. All right, it says now write down the IUPAC name of compound Y. All right, so we know with esters that the first part of the name, so with the ester, it's made from an alcohol and a carboxylic acid. All right, so it's made from an alcohol plus a carboxylic acid. They told me we had ethanol, okay? And ethanol has got 2 carbons. If I draw out ethanol, it's got 2 carbons and an OH group. So if I have a look at this molecular formula, it's C2. I've got 1, 2, 3, 4, 5, 6 hydrogens and an O. All right, I'm making an ester. And we just worked out now, the ester's formula was C8H16O2. Therefore, what is left? So these two, the carboxylic acid's molecular formula plus that of the alcohol must add up to the C8H16O2. All right, so let us just have a look. All we have to do now is actually subtract. Okay, so C8 minus C2 leaves me with C6. H16 minus H6 leaves me with H10. And O2 minus O leaves me with, of the 2, leaves me with an O. All right, so now I think I've made a mistake here somewhere. Oopsie, sorry. Where have we gone to now? All right, let me just get back to my question. All right, sorry about that. All right, so let me just get this here. So I'm looking at C8H16O. So obviously now we've got to work out the name of this. So sorry, it's C8. So the first part of the name comes from the ethyl, and the second part of the name comes from the number of carbons left. So it means C6, which then means hexanoate. All right, so let me just do that. So if there's 8 carbons in the ester, I take away 2 that belong to the alcohol, and I'm left with C6. So therefore, the alcohol or the carboxylic acid that I worked with was hexanoate. So the name of the ester is going to be ethyl hexanoate. All right, so ladies and gents, when we need to look at your esters, always remember the first part of the name comes from the alcohol and the second part of the name comes from the carboxylic acid. All right, and remember an ester is written as 2 words, so it's ethyl hexanoate and it ends in anoate. All right, and that was the name of the ester of compound Y.